Welcome back. We're writing Little Man Computer in C++, and last time we embarked upon the process of writing an assembler to allow us to convert a textual representation of the program we want the little man to run into the numerical format that we can put into memory. And we started, let's just check. Yes, so we started writing a simple test that ended up dragging on a little bit, just to convert a single halt instruction to a program that contained that single halt instruction, and we've teased out the idea of having an assembler with an assemble method that takes a vector of instructions that look like this, and that return a program, which is a vector of ints that can then be tested. So that first instruction gives us kind of a shape we can start working with to move a little bit forward. So there are a couple of options here. We can deal with address labels, or we can deal with addresses themselves, or we can deal with the remaining. I think dealing with the remaining instructions that don't take a parameter is probably going to be the easiest starting point for us, and I think working from easier to more involved is probably the right direction to go in. So if we look back at our instructions here, halt does not take a parameter, and input and output do not take parameters. So having input and output instructions is probably the next step along the path to where we want to get to. And also this will allow us to tease out the having multiple instructions in the program as well, as we kind of always want to finish with a halt instruction. So a single input instruction and a halt is translated to 9010. Essentially, let's capture the relevant things. So it is 901 is an input, so that's INP. We can then steal the idea there of, in fact, let's just copy this. We are going to very quickly want to break this out into something better, but for now this is okay. So that's going to be program 0, and that's going to be program 1. We have to watch out for segmentation faults that are somewhat spurious due to not having populated a 2-element program yet, but that's fine. So this is going to fail due to a lack of program, and I think I'm just going to be brave and steal the entirety of that for now and duplicate that instruction like so. A little bit aggressive there, but I think that's safe in this context. So we've created a sequence of instructions with an input and a halt, and we've then created an assembler. We've called assemble with the instructions, and that returns a program. And I mean, we were probably a bit ambitious creating a whole class for this assembler initially, but we are going to need to capture a few bits and pieces like the lookup table for labels. So I think having that class is reasonable. And then we check that 9010 is our program. Good, and if we run that, we should find that we have a segmentation fault because we've only got one value. If we extract a proper evaluation assertion method for lists, we can put in the check that the vectors are the correct length as a first check, so we won't get to having that segmentation fault. I mean, we could even start with that now just to get rid of that. So we want to say program dot. Oh, how do you find? how does one get the length of a vector in C++? Oh, is it just the size? Yes, I'm sure we've done this before. Yes, it's just .size. So what we want to say is that program.size equals 2. And I think we can see that fail without a segmentation fault. Oh, in fact, it did fail without seg faulting there. That's but that's yes, that's slightly cheeky because that's because the first element was incorrect. If we were returning 901, then it would have seg faulted. So let's work with that for now, and then I think we want to, in the very near future, start pulling out some function to do the assertion properly. But we now have a failing test, so we can go to our assemble method in assembler.cpp and actually do something useful with the instructions here. So we can initially just adjust that slightly so that we are just refactoring the way that works, and that should leave us still with the same failure profile, but we've now got something more sensibly structured to go forwards with. That's good. And then how we can do away with this as well. And so then we need to start looking at the instructions. Now I won't put a loop in straight away. I think that's a little bit too ambitious, but we can say something like if instructions 0.code is equal to input, then we can do this. Very delicate steps. We are also always adding the halt instruction without checking that the halt instruction exists, and now we pass. That's good. We're adding the halt instruction without checking that halt instruction exists, which is fine for now. Later we'll be able to correct that behavior by having trailing dat instructions to reserve memory locations, and then this will no longer be a valid thing at the end. But that's good. So that's got us a passing test. I don't think there's any obvious refactorings in here, but I would quite like to pull out something here that compares two vectors. I think that would get us something a little better. So to prepare for that, what I want to do here is to have this kind of formulation, like so, and then I can replace this with expected program 0. And I can do the same down here with expected program like so. And we can say that the sizes are the same and that the first instruction is the same, and so on. This will allow us, if we pull this out into something, into a function, to start doing something a little nicer as well on the feedback front as well. We can have a slightly better error message than fail, and say give some hint as to, you know, why in particular it failed. I think that would be beneficial. But for now, let's just get to the point where we can do an assertion. So this is good. We have two vectors, and we're manually comparing them now, but we will properly compare them later. I'm going to just copy that, and I'm going to go up here and find where we've got our current assertion, so that we can put it next to it. I can't find it. That's interesting. There we go. It's just up here. So we want to also have void assert Can we say are equal there without any confusion and have vectors as the parameter? Okay, let's do this just step by step for now and do a very explicit setup. We might end up wanting to template this later, but I think we're okay like this for now. And then what we can do is we can say we can put our little program in here, and that wasn't quite enough. No, that's not what I want, is it? What I want to do is then have we've passed, and then say passed equals that lot, although it doesn't really at the moment. So we'll have that as our first check. And then what we want to do is we want to say for I in, so we know if passed, I want to be a little careful here. That can go away. That's not quite right. I is less than program.size. We know they're the same size, so that's safe. And then increment. No. That's what I meant to do. I could have done that much more easily just using the equals key, but I didn't. And it's too late now. And then what we want to say is if oh, yes, I've used the wrong namings there, haven't I? Expected size, that should be actual. Doesn't matter which way round we do these, as they're the same. And then we can say if expected I is not equal to actual I, then we can say that passed is false, and we can break. And then we can write out the results here. And I shall leave us without any more detailed error message for now, as that should be okay. Now, let's just double check what we've done here. Assert are equal, it takes a vector expected and a vector of actual. It initializes the past variable to be whether they're the same size or not. If they are the same size, then it loops through and checks if there are any that aren't the same, and then prints out the result. That's good. Good. So we go back here. We can then change the assert are equal. Hopefully, just to do that, we'll just do it on this one first, just to check that nothing horrible has happened. What have I done here? Comparison of integers of different size. So let's make that. Do I have to? Oh, didn't mean to do that. Let us go back to that and change this. I guess we want to do something like that. Does that work? We're not going to get an enormous program in this because we're somewhat restricted on our memory locations, but that's the structure we have to play with at the moment. So then we can just say, we can actually just copy this line here because I'm lazy. And then we can delete that lot. So now hopefully we'll have that passing as well. And we'll have a much nicer structure that we can work with our assertions now. I won't go back and change the other tests yet, because in those cases I think we were comparing arrays with vectors and it won't quite work with the structure that we've put together. But for now I think that's okay. So let's just add one more test in here for output. So a single output instruction and a hold instruction is translated to 902. I think that's out, isn't it? So that should then fail suitably. And then we can make it pass relatively easily with a slight change here. Else if instruction 0 dot code equals out, we can do dot push back 902, and that should allow us to pass the test, which will be nice. And then we'll have a quick look and see. Oh no, we're still failing. What have we done there? We haven't changed the expected value. The joy of copy and pasting. So that should be 2. So now we can check. We also haven't changed the test name properly, have we? Oh no, we have changed the test name. That's a good start. I completely blanked there and didn't check the answer. Yes, that's fine. So, single output instruction is translated to 9020. We have an out, we have a hold, we have the correct expected program, and the tests pass. Excellent. And here we're starting to get a little messy, but I think I want a little bit more before I refactor this, just to give us some clarity of what we're after. I mean, we may come into some lookup table or some such to do this. but we will see. So let's see where we are on our status. That's fine. We now have assemble single input or output instruction. That's not how you spell assemble. Assemble single input or output instruction. Excellent. And next time we shall move a bit further.